So today we'll be doing unit circle trigonometry. A unit circle is a circle centered at the origin with a radius of 1, which can be used to measure sine, cosine, and tangent. If you need to review these trigonometric functions, check out our video titled Basic Triangle Trigonometry and come back here once you're done. The unit circle can be measured in degrees and radians. As you already know, there are 360 degrees in the circle. However, radians are a modern angle measurement based on the arc length of the unit circle. Let's move to an image of the full unit circle to explain this topic. This is the image of a unit circle that you are most likely accustomed to seeing, but let's break down the meaning of this in terms of radians and degrees. You can see the degrees labeled on here, and the measurement listed after the degrees is in radians. It increases from quadrant 1 to quadrant 4 in increments of pi over 6. Since the angles can be measured in units of radians or degrees, it is important to be able to use both and to convert between them. This is the formula for conversion between radians and degrees. Convert each degree measure into radians and each radian measure into degrees.
Say pause the video and play once you're done.
Pause the video and play once you're done.
Now you can say these are the actual answers.
These are the actual answers.
So can you explain the first two ones, just plugging them into the formula?
Yeah. So with the first two questions, you can plug them into the formula. So radians or degrees equals 180 degrees over pi times radians. In the second one, you can convert to degrees to radians by using the formula radians equals pi over 180 times degrees. So whenever you see a negative sign in a question like the first one, just know that you are simply moving from 0 to the fourth quadrant. You are essentially going through the unit circle in the opposite direction. You can now pause this video and try to complete the rest of these problems by yourself. Now, let's move on to the application of the unit circle in trigonometry. Let's look at the triangle for a second first. This is a standard 30, 60, 90 triangle, which we can use to find the sine, cosine, and tangent of, for example, the angle 30 degrees. And I'm going to quickly label the slides, and you're going to see why in a second.
Okay, I already labeled that part.
Okay. Draw one of the unit circles. This triangle that I just drew is the exact same triangle that you see here. The two triangles have the same angles, so they are similar. Therefore, corresponding sides are proportional. The hypotenuse of the triangle in the unit circle has length 1 because it is a radius. Since this is half of the hypotenuse on the right triangle, all of the sides in the unit circle triangle are half of the corresponding sides on the left. For example, the side adjacent to the 30-degree angle on the right is square root of 3. Therefore, the corresponding side on the triangle on the right has to be half that, or square root of 3 over 2. So now we can apply the definitions of the 6 trigonometric functions to the coordinates x and y. Let's try these practice problems now. I will go through the first one with you. Feel free to use the unit circle and remember to use the definition we learned in the last slide. Now you can pause the video and complete the rest of the explain. So the angle we'll be using for cosine of 2 pi over 3 is 60 degrees. Now the opposite side of this angle is root 3 over 2 and the adjacent side is negative 1/2. Because the hypotenuse is only 1 and cosine is adjacent over hypotenuse, we will be using the adjacent side over 1. And the adjacent side is negative 1/2. Because anything divided by 1 is the same thing, the cosine of 2 pi over 3 is negative 1/2.
Okay, now I'm going to reveal the rest of the answers.
Now we're going to reveal the rest of the answers.